Hey everybody, this is Mr. Lauer here. We were just working on this assignment here in the last video. We did 2 proofs already. So the first section of this is just describing how you prove a theorem. There's kind of some setup steps, and you got to kind of figure out what you can assume and what you can't assume, and you need to draw a picture and make some labels and things like that. So that's that part. In the previous video, we wrote a paragraph proof for this this theorem here. This is the supplement theorem. And then we also did a 2-column proof for the congruent supplements theorem, which is a different result. Right now what we're going to do is we are going to prove the vertical angles theorem. Before we get started with that, one thing that we need to kind of do quickly is we just need to review the previous 2 theorems, not the whole proof, but just the result, because we're going to use those results in this proof. Okay, so the 2 things that we've proven so far to this point is that if 2 angles form a linear pair, then they are supplementary. It's called the supplement theorem. So make sure you understand that idea. 2 angles form a linear pair, they're supplementary. Okay, the other thing you need to know is that if 2 angles are supplementary to the same angle, then they are congruent to each other. Okay, so here's a little picture I drew. If these 2 angles are both supplementary to angle 2, then they have to be equal to each other, or congruent. Okay. Now, we don't want to use specific angle measurements in our proofs, but just for an example to describe what's happening here, if this were 140 degrees, and I knew these 2 angles were supplementary, this would have to be 40 degrees, because supplementary means they add to 180, and 140 plus 40 is 180. Okay? Now, if I also knew that angle 2 and angle 3 were supplementary, angle 3 would also have to be 40. The idea here is that there's only one number that I can add to 140 to get 180. So if both of these angles are supplementary to angle 2, then they have to have the same angle measurement. They have to be congruent to each other. That's what this theorem says. Okay? We need both of those theorems, 2.3, or the supplement theorem, and theorem 2.6, or the congruent supplements theorem, for this proof. Okay? All right. Now, the vertical angles theorem says that if 2 angles are vertical angles, then they are congruent to each other. Okay? All right. Now, what we need to do here is we need to figure out what we are trying to prove and what we can assume. Okay? So the statement immediately following the if part is the given. We can assume that that's true. What we're trying to prove is the conclusion, which is the statement that immediately follows the then part of the statement. Okay? All right, let's draw a picture. Now for vertical angles, we need straight lines. Okay? Vertical angles are non-adjacent angles. They share a common vertex, and they're formed when 2 straight lines intersect. So in this case, the vertical angles here would be angle 1 and angle 3. Okay? Now the reason why I haven't used 2 yet is because I want to put 2 in the middle. Okay? Now these are the vertical angles so far. Okay? Whenever you have vertical angles, you have to have straight lines intersecting. And whenever you have straight lines intersecting, you get not just vertical angles, but you also get linear pairs. So if you notice, 1 and 2, angle 1 and angle 2 form a linear pair, and angle 2 and angle 3 form a linear pair. That's going to be an important part of our proof. Okay, so this is the setup. We need to translate the given and the proof statements into statements that use these labels. So given angle 1 and angle 3 are vertical angles. We can assume they're vertical, that's it. We can't assume that they're congruent, because that's actually what we're trying to prove. That angle 1 is congruent to angle 3. Okay? All right. So in this case, what we're going to do is a flow proof. Okay? Now a flow proof basically uses shapes and arrows to show the chain of reasoning. Okay? There's no specific direction that a flow proof has to go, but just based on the space that I have here in front of me, I'm going to go left to right because that's where I have the most space kind of going in this direction. So just like normal, we start with the given statement. Now the difference here is that I'm going to kind of put a bubble around the given information because we're using shapes in order to make this flow chart. So I'm going to put angle 1 and angle 3 are vertical angles. Okay, and sometimes you'll see, like in your book, they abbreviate angles to this. It's like the angle symbol with an S after it. They abbreviate the word angles using that kind of setup. Okay, so that's what we know. Now in a flow proof, the reason goes underneath the shape. So I know this is true because it's given. Okay? All right, now from here, what we're going to talk about is we're actually going to talk about the linear pairs because I don't really know a whole lot about vertical angles right now. I'm trying to prove something about them. Pretty much the shape here and the labeling is all I know. But if you look at 1 and 2, those form a linear pair. And what we've proved previously is that if 2 angles form a linear pair, then they're supplementary. So that's going to be important. So what I'm going to do is based on the fact that I have vertical angles, I also know that I have linear pairs as well. And so I'm going to state that angle 1 and angle 2 form a linear pair. Okay? I'm going to put that in a box this time. Now you don't have to do this, but sometimes if you want to get really fancy, you can use different shapes for the different types of justifications. So because this is a definition, I'm going to box on my definition statements. So how do I know angle 1 and angle 2 form a linear pair? Well, really it comes down to the definition of linear pair. A linear pair are 2 angles, 2 adjacent angles, whose non-common sides, this would be the common side, the non-common sides form opposite rays or form a straight line. So if I have straight lines intersecting, I basically have opposite rays here and here. And when I have those opposite rays, I have linear pairs. Okay? So the justification here is the definition of linear pair. Okay, now the branch, the reason for the branch is because I also have another 2 angles, right? And so I can talk about angle 2 and angle 3 forming a linear pair. And this result doesn't have anything to do with this result. They're kind of like independent of each other, but they both come from the fact that I have vertical angles. Okay, so I'm going to go def of linear pair. Okay. Now, we just talked about this idea that linear pairs are supplementary. Okay, if 2 angles form a linear pair, then they're supplementary. So directly off of this result and this result, I can say angle 1 and angle 2 are supplementary. I'm going to use an abbreviation there, sup. Okay. Now, how do I know that? Well, that's actually a theorem that we just proved. It was called the supplement theorem. So because we're using a theorem here, I'm going to change my shape up, and I'm going to use like a parallelogram or kind of a rhombus shape here. Again, this is kind of an extra detail. You don't have to do it this way, but if you want to get kind of fancy, you can say, okay, anything that I'm using a theorem for, I'm going to use a parallelogram or a rhombus. Okay, now this was called the supplement theorem, or it's called Theorem 2.3 in your book. Okay. All right, down here we know the same kind of idea, but we're talking about 2 and 3 here. So angle 2 and angle 3 are supplementary. Boop, boop, boop. Okay, so again we'll put maybe kind of a rhombus shape around there. And again, this is the same theorem. This is the supplement theorem, or 2.3. Okay. Now when you're doing a proof and you're writing the reason, you may forget the name of those theorems. You may forget the number of those theorems, and that's okay. If that's the case, just write the theorem in shorthand. So if I didn't know this was called a supplement theorem, I would say like, if two angles form a linear pair, then they're supplementary. In other words, I would just like write the theorem itself, and you can like abbreviate if you need to. So you can when you're stating a reason, you can state the name of the theorem, you can state the number, or you can just state the theorem itself. As long as you've already proven that it's true, you can use it. Okay. I think it's more convenient to know the names of them because it's less writing, but you know, that's up to you. Okay. So angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary. What I wanted to point out is we kind of have a situation like this. We have two angles that are supplementary to the same angle. And we know from this theorem that we proved just a second ago that if two angles are supplementary to the same angle, then they're congruent to each other. Okay? So in other words, if these two angles, angle 1 and angle 3, are both supplementary with angle 2, then they have to be equal to each other, right? Let's just imagine for the sake of argument that angle 2 is equal to 160. It's not, and we can't assume that that's true, but just to understand what's happening here, let's give it specific numbers just for a minute. Okay, if that's 160, and 1 and 2 form a linear pair, and they're supplementary, sorry, I'm just going to write this bigger for you, then this has to be 20 degrees, because they have to add up to 180. But if these two angles also add up to 180, then this also has to be 20 degrees, which means that these actually have to be the same, 20 and 20. Now, of course, we don't know for sure that angle 2 is 160, and we can't assume that it is, but the point is to just explain that result. We've already proven if two angles are supplementary to the same angle, they're congruent to each other. So what we're going to do is we're going to take these two statements and we're going to combine them to get a new statement. So 1 and 2 are supplementary, 2 and 3 are supplementary. That means that angle 1 has to be congruent to angle 3. How do I know that? Because we proved it up here. It's theorem 2.6, or the congruent supplements theorem. Okay. Now in this proof, we finally start to see the whole point and the whole beauty of an axiomatic system. The whole idea is as soon as we prove these two theorems, now we can use them in a proof, right? We just used theorem 2.3 and 2.6 to prove theorem 2.8. But guess what? Now we can use theorem 2.8 in future proofs, right? And then we can use those proofs in future proofs. And we get this snowball effect where we start to have lots more ideas, lots more pieces of information that all came from a very small set of assumptions, right? We have some definitions, we have some postulates, we had no theorems at all, but the number of ideas that we have is now growing, which is really cool. So sometimes it's a little overwhelming because we start getting like so many different ideas, but it all starts from a very small a very small set of information. Okay, so that's your theorem there for 2.8. Okay, I also wanted to go through a couple examples with you from your homework. Okay, so let me explain this sheet here. This is part of the handout. Now this isn't the homework assignment itself, so don't think that these are the only two problems that you have for homework. They're not. These are your example problems. So this whole thing was just part of the notes for today. Okay, so I wrote out your assignment for you so that you could see what it is, and then I wanted to give you some tips and tricks for these problems. Okay, now there's two problem sets. You got to do 16 through 24, and then later you got to do 27 through 32. And 27 through 32 are kind of like true-false questions. But instead of being true-false, you say it's sometimes true, it's always true, or it's never true. So it's like a true and false question, but with 3 options instead of 2. Okay? Those are pretty self-explanatory. But I wanted to go through problems like this with you so that you can understand how to set them up. Okay? Now first off, you don't have to do any proofs on tonight's homework. None of it's proofs. Okay? Now, I do want you to show your work, but that's different. Okay? Showing your work is not the exact same thing. So you're going to have problems like these in your homework. And we're going to look at both of these examples together. Okay? So first thing you want to do is you want to start by identifying the type of angles and angle relationships in the figure. In other words, do you have vertical angles? Do you have linear pairs? Do you have right angles? Do you have complementary angles? Right? You'll see something, or they'll give you information for that. In this case, we're talking about angle 1 and angle 2. Excuse me, angle 11 and angle 12, sorry. So what do we know about angle 11 and angle 12 based on this figure? Well, we know they're a linear pair, right? Just by definition of linear pair. There's your straight line right there. Okay. All right, well, what do we know about linear pairs? Linear pairs, if two angles from a linear pair, then they're supplementary. Okay, well, what does supplementary mean? It means that they add up to 180. So you don't have to write any of that down. I just wanted to kind of model for you the thinking that you should be doing here. Okay, these are a linear pair, therefore they're supplementary. They're supplementary, therefore their measurements add to 180 degrees. So what I'm going to do is I'm going to take these two expressions here. I have one for the measure of angle 11 and one for the measure of angle 12. I'm going to add them together and I'm going to set them equal to 180. Now we don't do that for every single problem. For this problem we wouldn't do that because these aren't a linear pair. So we have to answer some questions. We got to pose some questions to ourselves and then answer those questions. In this case the question is, what kind of angles do we have? And the answer is linear pair. So this is my equation. Now from here I'm just going to solve that equation. I'm going to start by combining like terms. And then I'm going to use properties of equality to get x by itself. Now if I were going to be kind of a stickler, I would say make sure you tell me all those properties, but for this assignment I'm not going to ask you to do that. However, if you're curious, addition property of equality, division property of equality, right? Okay, now the goal was to find the measure of each numbered angle. I haven't done that yet. I know the measure of angle 11 is equal to x minus 4, and now I have just discovered that x is equal to 63. So if I substitute in for x, instead of x minus 4, I have 63 minus 4, I get the measure of angle 11, which is 59 degrees. Okay. If I want to find the measure of angle 12, there's multiple ways to do that at this point. One of them is similar to what we just did. We're just going to plug that number into this expression right here, 2x minus 5, and we're going to figure out what that measurement is. So 2 times 63, that will be 126, and when we subtract 5 from that, we get 121. Okay, now just to check ourselves, to make sure that this actually makes sense, remember that angle 11 and angle 12 should add to 180 because they're a linear pair, and these actually do add to 180. So as a final check, we can kind of make sure that they do what we expect them to do. Okay, so that's an example using a linear pair. Now, like I said, not every problem is going to have a linear pair in it. In this example problem here, we actually have vertical angles instead, right? Now, if I had this angle, I could say these two are a linear pair, or these two are a linear pair. But 17 and 18, their relationship to one another is that they're vertical angles. Okay, so that's step one. Okay, then we want to use a fact, definition, postulate, property, or theorem to help us set up an equation for the angles. Well, in this case, what do we know about vertical angles? The vertical angles theorem says that vertical angles are congruent. And congruent means that they have the same measure. And so I know the measure of angle 17, which is 2x plus 7, has to equal the measure of angle 18, which is x plus 30. Okay, so the chain of reasoning there is vertical angles, therefore congruent, therefore measures are equal. Okay, then we're going to solve the equation for the variable, and we're going to substitute the value in if necessary. We actually did that here, I just forgot to go through the bullet points, but notice we solved for x, we plugged x back in. Okay, so step one, they're vertical angles. Step two, use that fact, in this case vertical angles theorem, to set up an equation. Vertical angles are congruent, therefore measurement equals measurement. Okay, now we're going to solve for x. So I'm going to group my x's on the left here, and at the same time I'll group my numbers on the right. Looks like x is equal to 23. Okay, now remember that my final answer, or my final the final answer should be the measure of the numbered angles. So I'm going to plug 23 back into this expression to figure out what that angle is. So 2 times 23 is going to be 46. I'm going to add 7 to that, and that is going to give me 53. Now remember that a second ago we said that the measure of angle 17 and 18 should be equal to each other. So if I substitute 53 sorry, not 53, excuse me, 23 into this expression, I should expect to get the same thing, and I do. So sometimes my angles don't match, and sometimes they do. It just depends on what kind of angles we're talking about. Okay? So there's my final answer. There's my final answer. I got the measures of all the numbered angles. In this case, they're congruent. In this case, they're supplementary. Okay? So use this as a guide to help you on these problems 16 through 24. Okay? Most of them are pretty straightforward. And if you're not sure where to go, this is what you want to do. You want to start by identifying the types of angles, and then what does that term mean, or what does that term tell you? Use that information to set up and solve equations. Cool. Hope that helps, guys. Thanks for watching. See you in class.